before we dive into the assertion it is, some distance greater persuasive to sort out what molecular gasoline pedals are. The Big Hadron Collider LHC operated by way of CERN is a 17M ring of superconducting magnets. In addition, it is the world's most prominent and most note where the atom smasher it represents the pinnacle of human fulfillment. As a matter of fact, it is so powerful that it may reproduce the precise state of the first moment on Earth. However, could the machine intended to open the mystery of the universe hold the key to something truly unique? Founded in 1954, CERN is one of the world's most famous research institutions with 23 member states and countless researchers. It's an area for collaboration and innovation. The LHC is CERN's undertaking, but it is only one part of a huge organization of fuel, pedals, and exams. Consider a course not much for motors or humans, but for subatomic debris in a trial of flare. Staying power in space itself, the LHC accelerates protons to almost the speed of light, sending them on a collision path that reflects the energy of the universe. Right after the Big Bang, the impacts create temperatures much warmer than the center of the sun. A massive number of magnets guide the protons on their journey, while complex cooling systems hold the magnets at temperatures less hot than space. The beams in the LHC are made to crash at 44 locations across the gas pedal ring, connecting with the spots of 4 particle detectors: Atlas, CMS, Alice, and LHCb. Each fills a specific purpose, investigating different additives of particle physics. Together they act as massive cameras, taking photos of these collision. Scientists then sift through the particles, searching for signs of the elusive Higgs boson, also referred to as the God particle, and other anomalies that could provide clues about the universe's essential building blocks. By focusing on the microcosm, we gain insights into the universe, but with every answer comes another question, and with every discovery in another challenge emerges. Though LHC isn't only a scientific tool, it's an exhibit of human interest in progress. It represents our entrepreneurial mission for understanding and our desire to recognize the key forces that shape our universe. However, as we push the limits of what we know, we must also bear in mind the more profound and existential questions that arise. What are the risks of probing the unknown? Should our quest for information inadvertently unleash powers we have no control over? Inside the sacred halls of CERN, where the boundaries of human knowledge are constantly driven, a revelation has arisen that sends a shiver down the backbone of even the most seasoned scientist. Brian Cox, former scientist at CERN and a voice of understanding in the field of particle physics, has recently said something that has left the world both enthralled and uncomfortable. Cox's words resound with chilling clarity. The reason for CERN's Large Hadron Collider is to recreate a mini Big Bang. Yes, you heard that right, a small version of the very event that gave birth to our universe. The physicist also went on to explain the ramifications of this goal, highlighting the LHC's great potential for making new discoveries. This includes its potential to discover the secrets of the Higgs boson and explore dark matter, mysterious substance that makes up a sizable part of the universe. Imagine holding the strength of creation in your hands, the ability to summon the VAR essence of the universe. It's an attractive possibility, but one fraught with risk. The mini Big Bang isn't just a theoretical idea, it's a completely real phenomenon within the LHC. The temperatures, the pressures, the raw energy, all of it recreates the conditions of the universe. Started like standing on the dawn of recorded history, witnessing the beginning of existence itself. But with such power comes responsibility, and the question looms, what if something goes wrong? In fact, something did go wrong back in 1978, Russian physicist Borsky encountered a catastrophe that might forever change the course of his life while working at the U-70 synchrotron at the Institute for High Energy Physics in Penno, Russia. Failure caused his head to accidentally enter the direct path of a proton beam. The beam with a pressure that defies notion passed through his skull, entering the back of his head and exiting through his nose. Borsky's experience was harrowing. He saw a flash brighter than 1,000 suns, but had no immediate concerns. The beam's path left a trail of destruction, burning tissue and bone, but he remained conscious and even walked to the center for treatment. The outcome was both troubling and surreal. The beam caused localized tissue damage, leading to hearing loss in one ear and partial facial paralysis. Remarkably, Bohr's cognitive abilities remained intact, and he continued his medical career. This incident serves as a reminder of the great energy and potential dangers of particle accelerators. The risks of a particle smasher like the LHC to be underestimated. The potential for catastrophic reactions, the very fabric of life being altered. These aren't the stuff of science fiction, but our worries. Voiced by respected scientists, one of the most unsettling and captivating issues associated with the LHC's experiments is the possibility of creating a miniature black hole. Black holes are areas of space-time where gravity is so strong that not even light can escape. They are massive vacuum cleaners, devourers of stars, and mysterious entities lurking within the shadows of our universe. The fact that the LHC could potentially create one of these phenomena, even on a small scale, is awe-inspiring to both the public and scientists alike. Could this black hole eventually grow, developing out of control and swallowing the Earth from within? Scientists at CERN have reassured the public that any black hole created would be unstable and disappear in no time. Nonetheless, the remote possibility has sparked debates, fears, and a sense of the power we wield. It's important to understand how the LHC might create a black hole. It's all about the basic mechanics of particle accelerators. When protons are smashed together at nearly the speed of light, the energy produced is so immense that it distorts the fabric of space-time itself. Imagine a trampoline stretched tight, then a heavy object dropped onto it. The fabric bends, and if the object is heavy enough, it can create a well so deep that anything nearby will be drawn into it. This is an analogy for what could happen in the LHC inside the realm of quantum physics, where the laws of the universe are both strange and wondrous. There's a hypothesis that more dimensions might be hidden within our reality. If these dimensions exist, the LHC experiments could tap into them, creating a gravitational well that forms a small black hole. This peculiar dance of particles has even caught the attention of some respected scientists, notably the late Stephen Hawking. In his book, he warned of a scenario in which the Higgs boson could become risky at very high energy levels. This instability could see you a catastrophic event called vacuum decay, an event that wouldn't just destroy Earth but could potentially destroy the entire universe. The renowned English cosmologist and astrophysicist Sir Martin Rees also expressed concerns about the experiments carried out at CERN. In his book At the Future Possibilities for Mankind, he explored the potential risks of particle smasher experiments, including those at CERN. His words weren't just careful, they were filled with a sense of existential dread. He examined a worst-case scenario in which a failed experiment could trigger a phase transition that would ripple through the fabric of space-time, resulting in a disaster that could engulf the entire universe. Concerns we not confined to theoretical musings. He assigned a low chance to these catastrophic outcomes, but he argued that even a small risk warrants serious attention. Stakes are high and the margin for error is razor thin. The Scientists at CERN have run simulations, analyzed theories, and taken every precaution to ensure the safety of the LHC. In fact, Brian Cox himself emphasized the importance of these measures, acknowledging the inevitable concerns and questions surrounding the LHC's operations. He reassured the public that there are rigorous safety protocols in place, thorough reviews and processes to ensure the LHC's operations are done with the highest degree of attention to detail. Cox reassured the public that the energies involved are well within what the Earth naturally experiences, and that the chances of developing a stable black hole are astronomically low. Even if one were created, scientists say it would be so tiny and volatile that it would quickly dissipate in an explosion of energy, a phenomenon predicted by Stephen Hawking called Hawking radiation. It would be a fleeting moment of cosmic wonder, a short glimpse into the void, and then long gone. Some have taken the idea even further, speculating that the LHC's experiments could open a gateway to another universe or dimension. While this idea is largely dismissed by mainstream scientists, it has captivated the imagination of many and become a topic of intrigue, fear, or even myth. What lies beyond our universe? Could we accidentally unleash forces or entities that we do not understand? The concept of opening a door to hell has even been sensationalized in various media, fanning the flames of uncertainty. However, how did this idea come about, and what does I mean in terms of scientific exploration? The concept of more dimensions is not new in physics. String theory, a leading contender for a unified theory of everything, suggests that they may be more than the standard 3 dimensions of space and 1 of time. These extra dimensions could be compactified or hidden from our perception, but in theory, they could be accessed or discovered under extreme conditions. Now consider the LHC as a large key, opening doors that have been locked since the dawn of recorded history, when protons collide at energy levels never before achieved on Earth. They might, in theory, create ripples or waves that probe these hidden dimensions. If these dimensions exist, the LHC may indeed discover them. But before we get too excited with wild speculation, it's important to remember that while the LHC is certainly powerful, there is no definitive evidence to suggest that it will open a door to another universe, let alone to hell itself. Though the allure of the unknown, combined with the mysterious nature of quantum physics, ensures that such ideas will continue to captain at the public imagination. Should we be concerned about the LHC and its potential risks? It's easy to be swept away by sensational headlines and fears of world disaster. However, the reality is that the scientists at CERN are highly aware of the dangers involved. They have taken every precaution to ensure their experiments are safe and continue to monitor and test their work with the utmost diligence. The potential benefits of the research, the breakthroughs in our understanding of the universe, the discovery of new particles, the exploration of dark matter are truly remarkable. It's not only a showcase of human ingenuity, but a window into the very heart of the universe. But like any great advancements in science, it comes with its share of risks, and we must approach it with a balance of wonder, respect, and caution. The Large Hadron Collider represents the frontier of scientific inquiry, where theoretical physics meets experimental reality. Its true potential to answer fundamental questions about the universe, including the origins of mass and the nature of dark matter, is immense. Yet despite rigorous safety measures and extensive simulations, the LHC still inspires a sense of mystery and fear. In soon as sheer scale of the device and the energy it generates are awe-inspiring, and each new experiment opens the door to uncharted scientific territory. While most scientists remain confident about the Safety of LHC experiments there are. Fundamental uncertainties, what if new? Unexpected anomalies arise that challenge our understanding of physics and the laws of the universe. The LHC pushes the boundaries of human knowledge and tests the limits of our control over the natural world as particle collisions mirror conditions hidden since the Big Bang. The importance of these experiments rose, raising existential questions about the potential effects of changing the very fabric of the universe.